Okay, let's unpack this. We're about to take a deep dive into something truly fascinating. The the long and, well, winding history of artificial intelligence.
Yeah,
You've shared this report with us, The Art of Artificial Intelligence. And our mission today is basically to use that as our map. We want to pull out the key pieces to really understand this whole journey.
absolutely. And what really jumps out from the source is that, this history isn't just a straight line upwards. Not at all.
Right.
It's much more like waves. You get these periods of incredible excitement, real optimism.
The AI summers, yeah.
Exactly, the summers, and then they sort of crash into these moments of, well, disappointment. The AI winters.
So it's a cycle, big dreams hitting the wall of what's actually possible at the time.
That's a great way to put it. Ambitious dreams meeting real-world limits.
Okay. And this deep dive, using your source here, it seems like we're going way, way back, like centuries even, before we even get close to modern AI.
Oh, yeah.
Yeah.
Millennia, actually. The idea is ancient. We have to touch on that before we land in, the computer age and machine learning. It's quite an arc.
An arc of ideas, then. Philosophy, mechanics, maths.
And eventually, yeah, computation and just massive amounts of data.
Okay, so let's start at that beginning, or like you said, the idea of the beginning. The report mentions stuff way before computers. Where does that thread start?
Well, what's fascinating, and the source highlights this, is that this urge to create intelligent things, or things that seem intelligent, it's not new. It goes way back.
How far back?
Ancient myths, Greek legends, for instance. You have stories of automatons like Talos, the giant bronze guy protecting Crete,
Right, I've heard of Talos.
or Hephaestus crafting these mechanical servants. It's embedded in mythology.
So kind of like ancient science fiction almost. Did that dream then become like physically real later on?
In a way.
Yeah.
Later on, you definitely see people building intricate mechanical automatons, clockwork things. Yeah. Inventors in the Islamic Golden Age, like Al-Jazari back in the 12th century, made some incredible devices. And then later in Europe, 18th century, guys like Jacques de Vaucanson built these amazing clockwork ducks and musicians.
Wow. But they weren't thinking right, just mimicking.
Precisely. The source is clear on that. Complex clockwork, amazing mimicry, but zero actual decision-making or intelligence. Just following a program, basically.
But the report also mentions people laying the groundwork for machines that could handle logic. Leibniz, Boole.
Absolutely critical. Maybe not seen as AI groundwork then, but crucial now. Leibniz, with his ideas on symbolic logic and binary. That's the root of computation.
Binary of ones and zeros.
Exactly. And then fast forward to the 1850s, George Boole nails down the math for logical operations. Boolean algebra.
The AND, or Minji-Goat.
That's it. The fundamental logic that, well, everything digital runs on today.
Okay, so we have the ancient dream, the clockwork mimics, and the mathematical foundation. But the big leap towards actual thinking machines? The report really seems to focus on Alan Turing.
Yeah, Turing is pivotal. He asked that fundamental question. Can machines think? His 1950 paper, Computing Machinery and Intelligence, it wasn't just philosophical.
He proposed the test.
It proposed the imitation game, yeah. What we now call the Turing test. Could a machine hold a conversation so well you couldn't tell it wasn't human? That was the benchmark he set.
And even before that, his theoretical work, the universal machine idea, that was key to even thinking you could build such a thing.
Absolutely fundamental. His 1936 paper on the Turing machine. It basically proved, theoretically, that a single machine could perform any possible computation if you gave it enough tape and time.
So it proved general-purpose computation was possible.
Exactly. Without that concept, the idea of building one machine to simulate something as complex as human thought would have been, well, much harder to even conceive of.
Okay, so all this brain power, this building momentum, it leads to a specific moment, often called the birth of AI.
That's right. Usually points to the Dartmouth Conference, summer of 1956.
Dartmouth 56.
Yep. Widely seen as the official kickoff for AI as its own field. You had John McCarthy, Marvin Minsky, Newell, Simon. A whole group gathered with this explicit goal to figure out how to make machines intelligent.
And the feeling there was super optimistic, wasn't it? Like, we'll crack this soon.
Oh, incredibly optimistic. The source calls it the start of the first AI summer. Money started flowing, especially from the government.
And they built stuff pretty quickly.
They did. Early programs seemed really promising. Newell and Simon's logic theorists could prove math theorems. Then the general problem solver seemed like it could tackle anything.
And Eliza, the chatbot, that fooled people, right?
It did. ELIZA showed how even simple pattern matching could look like understanding. It simulated a therapist, and yeah, some people really thought it got them.
But it didn't really get them.
Not at all. And that's the catch with those early systems. They were based on handcrafted rules. Very clever, but very brittle.
Brittle, meaning?
Meaning they worked okay in their super narrow, predefined little worlds. But step outside that. They broke. They had no common sense, no real understanding, couldn't learn or adapt. It definitely wasn't general intelligence.
Which, following that pattern you mentioned, cycles, led to the downturn, the first AI winter.
Exactly. Hit around the mid-70s, lasted till about 1980. Those grand promises from the 50s and 60s, they just hadn't panned out.
Reality check time.
Big time.
Huh.
The systems were too fragile, took forever to program, and honestly, the computers back then just weren't powerful enough. Not enough memory, not enough speed for what they were trying to do.
The vision outran the technology.
Massively. The gap was just too big.
And when the hype dies and the results aren't there, the funding disappears.
Yep. Government funding especially got cut way back. DARPA pulled a lot out. Commercial interest cooled. The whole field just entered this period of, disillusionment. Less activity, less buzz.
But AI didn't just vanish, did it? The source says it kind of reinvented itself in the 80s. Something called expert systems came along.
That's right. This was the field learning, adapting after that first winter. Thought, okay, maybe general intelligence is too hard right now. Let's pivot.
Pivot to what?
To building systems that captured expert human knowledge, but in very specific, narrow areas. Explicit rules, but focused.
So not trying to build an artificial human, but maybe an artificial geologist or doctor.
Exactly like that. The report mentions key examples. MYCIN, for diagnosing bacterial infections. XCON, which Digital Equipment Corporation used to configure their big computer systems, a really complex job.
And these worked. They were useful.
They were rule-based, yeah. But because they were so focused, they became practical. Commercially successful for a while.
And they even needed special computers, LISP machines.
Yeah, for a time. LISP was the main AI language then, so specialized hardware popped up to run it efficiently. This was AI moving out of the labs and into actual businesses. You saw it in finance, mining, medicine. Felt like another AI summer was starting.
Okay, narrow AI finds success, leading, inevitably it seems, to the second AI winter. What happened this time?
Yeah. Well, connecting back to the cycles theme, it was kind of similar issues, just in a new wrapper. Brittleness again, and cost. This hit around, say, late 80s to early 90s.
So the expert systems weren't perfect either.
They worked, but they were incredibly expensive to build. You needed specialists to interview the human experts for months, translate that knowledge into rigid rules.
Painstaking work.
Very. And maintaining them was tough. If something changed in the real world, updating the rule base was a nightmare. They couldn't learn or adapt easily. Still brittle, just in a different way.
And I guess regular computers were getting better and cheaper all the time.
Exactly. The specialized LISP machines suddenly looked way too expensive compared to powerful new workstations and PCs running more standard software. The cost benefit just flipped.
So the niche advantage disappeared.
Pretty much. And the term AI actually got kind of toxic again. Companies started rebranding, calling it advanced computing or knowledge-based systems. Anything but AI.
Wow. So twice the cycle repeated. Hype, limitations, crash. How did AI claw its way back this time? What changed?
This is where the really big fundamental shift happens, according to the source. The rise of machine learning, starting in the 90s, really gaining steam in the 2000s.
Machine learning, okay.
Researchers basically started moving away from that painstaking job of trying to write down every single rule by hand. Instead, they focused on building systems that could learn the rules and patterns automatically from data.
Learning from data instead of being explicitly programmed. That feels like the major turning point, the one that leads us to today.
It really, really is. Machine learning became the dominant approach. The whole focus shifted to algorithms that get better with experience, with more data.
Using different techniques.
Yeah, things like supervised learning, learning from data that's already labeled, like pictures tagged cat or dog. Unsupervised learning, finding hidden patterns in unlabeled data. And reinforcement learning, learning by trial and error, getting rewards or penalties.
And what kinds of algorithms made this possible early on, before deep learning took over?
The source mentions a few key ones from that era. Support vector machines, good for classification tasks. Decision trees, making choices based on data features. Bayesian networks, handling probabilities. But maybe the biggest single enabler.
Data.
Data. massive amounts of it becoming available, especially thanks to the internet. Suddenly, there was raw material for the machines to learn from.
Right. More data, better learning, the fuel for the fire.
Exactly. This whole shift set the stage perfectly for what came next, the era we're in now. The AI renaissance, you could call it, driven largely by deep learning.
Deep learning, which uses neural networks, right? And you said those ideas were old, from the 50s.
The core concepts, yes. Artificial neural networks, loosely inspired by the brain structure. The idea was there way back. People like Rosenblatt with the perceptron.
So why didn't they take off then?
A couple of big reasons. One, training them was incredibly computationally expensive back then. Computers just weren't fast enough. Two, and maybe more importantly, we just didn't have the sheer volume of data needed to train them effectively. They need tons of examples.
So what changed? Why did deep learning suddenly explode around the 2010s?
It was like a perfect storm, really. Three things came together just as the source lays out.
Okay, what were they?
First, big data. Truly massive data sets became available. Images, text, user interactions online, just enormous amounts of raw material.
Check. Big data. What else?
Second, a massive leap in computing power, specifically GPUs, graphical processing units.
Graphics cards for games.
Yeah. Turns out the parallel processing architecture that makes GPUs great for rendering graphics is also perfect for the kind of matrix multiplications needed to train deep neural networks really fast. Much faster than traditional CPUs.
Okay, so big data, fast hardware. What was the third piece?
Algorithmic improvements. We figured out better ways to train these networks. Techniques like backpropagation have been around, but refinements made it practical to train networks with many, many layers, deep networks.
And being deep is what makes them powerful.
Yes. Those multiple layers allow the network to automatically learn features at different levels of abstraction, like from pixels to edges to shapes to objects. It learns the hierarchy itself from the raw data, which earlier machine learning methods struggled with.
And this is where we start seeing the breakthroughs we hear about now, things like AlphaGo, ChatGPT.
Exactly. This combination, big data, GPUs, better algorithms, unlocked the power of deep learning. You saw it dramatically in 2012 with AlexNet winning the ImageNet competition. Huge leap in image recognition.
I remember that, making waves.
Then progress in understanding and generating text just accelerated with models like Google's BERT and OpenAI's GPT series, revolutionized natural language processing.
And AlphaGo beating the World Go champion in 2016. That felt like science fiction becoming real.
A huge milestone.
Yeah.
Showcased deep reinforcement learning, tackling a problem humans thought needed, intuition, creativity, learning strategy through self-play on a massive scale.
So suddenly AI wasn't just in labs, it was everywhere.
Pretty much. Voice assistants on our phones, recommendation engines deciding what we see online, analyzing medical scans, powering experiments in self-driving cars, even helping create art and music. It's deeply embedded now.
Okay, so stepping back, the report we've been digging into paints this really clear arc. Starts with ancient dreams, gets mathematical legs, has these bursts of early optimism with rule-based systems.
Followed by the winters.
Right, two big reality checks, the winters. Then this fundamental pivot, moving away from writing rules to learning from data with machine learning.
The critical shift.
And finally, the current explosion fueled by deep learning, which needed that perfect storm of big data, compute power, and better algorithms to finally work at scale.
That sums up the core narrative beautifully, yeah. The whole history is about navigating those cycles, the hype and the disappointment, but ultimately leading to this fundamental change in how we approach building intelligence, from telling machines rules to letting them learn from examples.
And it means when you interact with something like ChatGPT today or see what systems like AlphaGo can do, you can actually trace that lineage back through the winters, the expert systems, Turing's questions, even those ancient ideas.
Understanding that journey, from Turing asking, can machines think, to the tech in your pocket, it gives you vital context. It helps make sense of why AI is the way it is now, how we actually got to this point. It grounds the whole discussion.
Absolutely. And the source material makes it clear this isn't just a technical story. This progress brings other things to the surface.
Yes, definitely. As AI gets more capable and woven into society, the sources rightly point out these other critical issues. Things like bias creeping into algorithms trained on biased data.
Privacy concerns, too, with all that data needed.
Huge privacy concerns. Questions about the impact on jobs. And this big challenge of transparency. How do we understand why a complex AI made a particular decision?
Which can be really hard with deep learning models. The black box problem.
Exactly. So this historical view helps us see that these ethical and societal challenges aren't separate issues. They're emerging directly because of AI's current capabilities
Yeah.
and the path we took to develop them.
It's like the next layer we have to grapple with now that the technology is so powerful. And the report ends on quite a note saying this whole machine learning, deep learning era, it's only the beginning of what's still to come.
Yeah, that's a really thought-provoking way to close. Suggests this arc isn't finished criminal longshot.
So thinking about everything we've just discussed in this deep dive, drawing on your source, thinking about those patterns, the cycles, the big shifts driven by new tech or new needs, the impact of things like data and computing power, here's something for you, the listener, to really mull over. What does this history suggest might be next? What are the potential future turns, the next set of challenges? How might the lessons from those past winters and summers shape what AI becomes? Looking back like this gives you, I think, a really unique viewpoint to consider where things might go.